2.
Hello, we are Team 46032. It's going to be okay from Team Arizona, the Hot Route 66. We had a great year. Here are our trophies from regional,
state,
and worlds.
So we'd like to share our robot presentation with you. Right here is our Robot Design Finalist Award for Worlds. And so we'd like to share this with you. So we both contributed ideas for building our robot. His name is Beep. He has 2 drive motors, 2 attachment motors, a light sensor, a gyro sensor, and a micro SD card.
Our mission strategy includes of all 15 missions, across FLL ones have planned for the robot return zone, combining close missions and writing down failure modes after each match.
This year we've programmed in MicroPython instead of the EV3 Mindstorms language that we've used in previous years. This is because MicroPython has a faster loop time and we were both familiar with the Python language before the year.
We discovered how to use EV3 MicroPython using PyBooks.com as a programming resource. MicroPython has a fast loop time in EV3 Mindstorms, which are good for gyro drive straight, gyro tone, and motion profiling.
A useful resource was a video by Warren Robotics, who used a color sensor to know which attachment was on the robot. This was very helpful to decrease our in-home time. Here's some more building and programming attachments, programming resources that we used to improve speed.
We built our robot together. We both contributed and were included in building attachments and programming. I programmed built attachment for left side field, and Sam programmed built attachment for the right side field. We set a goal to solve all the missions, and we have built attachments for and programmed all 15 of them.
One of the attachments that I built and programmed is the feed the whale attachment. It works by driving into the whale and using this arm to tip the whale's mouth open, which in turn tilts this and all the krill into its mouth. It also simultaneously drops off the 3 coral segments and grabs the plankton sample.
One attachment I built and programmed that I find innovative is coral nursery attachment. I find it innovative because it does 4 different actions with only 2 motors. And for 3% of the match with this attachment, we score 15% of the points. That's 90 points.
We use the gyro sensor and the motor rotation sensor and our gyro drive straight function so that we can turn and drive straight accurately even if we're knocked off course. We use the gyro sensor and a proportional controller in our gyro drive straight function that includes a ramp up and a ramp down. This prevents our robot from jerking and sliding because it provides a gradual start and stop to all of its actions.
We measure the red, green, and the values and plot it in a graph measures that point on all our target killers. It's a closest kill in 3-dimensional space. Here's our code and how we've tested it. For the killer function that determines what attachment is on the robot.
Our innovative color function knows which attachment is on a robot by recognizing 13 different colors of Legos and even allows us to create new colors by mixing pizzas. Opposed to EV3 Mindstorms where it's 7 and Spike Prime it's 8. It saves us from having the wrong program for the attachment and even recognizes when no attachment is seated on the robot.
We use a master program to save time. Innovative master program saves us from the wrong program for the attachment by using light sensor and care function. Also displays gyro angle and the next launch on the robot screen.
We use these 2D frames to guide our attachments down onto our robot. This allows us to be 3 leg units off in either direction and also allows for an easy and fast seat and removal of our attachments.
One of our most innovative programs is motion profiling. We use it for the Kraken's treasure because it wiggles the treasure chest less, allowing us to grab it more solidly.
We've improved gathering up the loose pieces on the right side of the board, which originally took 16 seconds and now only takes 3. Part of our process is using a reliability chart to effectively target missions for improvement that are low in reliability in points per second. We also write down failure modes after each match, which helps consistently improve our scores throughout the year. This is an example.
We improved our robot and code multiple times. One example is removing the ultrasonic sensor. We tested and we discovered background noise made the ultrasonic sensor unrepeatable. Also, it's too big a field of view for our uses.
We tested the static coefficient of friction between all the wheels on the mat using a video by Integral Physics as a reference source. We chose our robot's wheels because they had a very large diameter, they had the highest static coefficient of friction, and we discovered that the cleanliness of wheels also dramatically changed their grip on the mat. So we learned that it's good to frequently wash our robot's wheels.
From our experience, lessons we have learned, we made a robot design research for other teams. We shared it with 3 other local teams, all the teams regional, state, and wards. We also shared it on a YouTube channel. We are proud of many things, including motion profiling, a trident attachment, and the growth made along the way.
Thank you for your time today, and make sure to check our YouTube Google Drive shared folder.
Do you have any questions?